Welcome to ClickMyProject.com. Let me discuss about the process QoS and energy efficient resource allocation in Uplink SC-FDMA systems. Let me discuss about the abstract of the project. In wireless sensor networks employed with multiple channels in order to reduce the interference as well as support parallel transmission, energy usage over the network dramatically increased because of usage of multiple channels. To overcome this problem, which was addressed above statement, have been achieved by proposed a regret matching based channel assignment algorithm. In this strategy, each sensor node its choice of channels based on the channel state information, which leads to reduce the interference. In a RMCA approach is more distributed over network and limited information is exchanged among sensor nodes so that can achieve minimum delivery ratio, even less number of flows performed. This algorithm performed well for time variant flows and network topology. It provided better network performance in case of delivery ratio and packet latency compared with the existing methods such as control, MMSN and randomized CSMA. Deploy the sensor nodes over network and assign the non-overlapping channel for receiving packets from various sensor nodes. The utility function is derived based on the packet delay rate, good put, energy efficiency and fairness. Based on the utility functions, all sensor nodes are completely measured without exchanging the information among other nodes. At last, channel assignment by RMCA to the time invariant transmission flows to reduce interference efficiently. Let me discuss about the flow diagram for our process. Initially, start the flow and assign the user into descending order. In the receiver-centric channel assignment way, the sender uses to send is determined by the receiver of the transmission, and the receiver-sender relationship is determined by the flows in the network and the network topology. Instead of explicitly coordinating, each sensor node only relies on history of its observation. Next, the regret matching based channel assignment algorithms perform a modified channel game for achieving better trade-off conditions. Next, if the BSR is greater than 0 and SR is the lesser as this minus 1 means sending request and buffer status reports is less than 0 means then the condition is terminated. Else then it will generate the users, it will assign the users. The system purposes recursive approach to compute the estimated average regret. Based on the recursive approach, we summarize the regret matching based on channel assignment algorithm. In this resource allocation steps, the probabilities assignment is based on the history of past experience. The channel assignment by RMCA can adapt itself to the variations of the flows. The sensor node only receives the packet from the sender in each stage. In the game theoretical framework, the problem is formulated as a multi-agent, multi-objective problem. Finally, we analyze the performance. 3 main metrics has been analyzed here: bit rate, fairness ratio, and packet delivery ratio. Throughput has been analyzed in the performance graph. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click the file and run for executing this process. Here we have to enter the number of users to be performed between 100 to 150, and here after that enter the channel bandwidth between 5 MHz to 10 MHz. Enter the subframe length, default 1. Enter number of resource blocks to be allocated for every users between 50 to 60. Enter number of subcarrier per resource blocks. For every resource blocks having minimum number of subcarriers, so the number of subcarrier will be 10 to 15. Here enter number of symbols per resource blocks. Every resource blocks having many number of symbols. Here we have to enter the number of symbols for every resource blocks. Enter subcarrier spacing between 12 to 15 kHz. Enter transmission antenna gain default 0. Enter receive antenna gain from 15 to 18 dBA. Enter maximum UE transmission power from 23 to 25. Enter target received power from -57 to -60. Enter uplink path loss compensation factor from 0.7 to 1. Moving average calculation factor from 0.2 to 0.5. Maximum distance from E node B from 330 meter to 350 meter. Here we have calculated the capacity of channel state information and we perform the analysis. This performance graph not based on our base paper work. Here this is the average users capacity for our proposed and existing method by varying the number of femtocells. This is the values of the average users capacity versus number of femtocells. This is the average users capacity obtain the overall average capacity users capacity. This is the outage probability by varying the SNR value from our between existing system and our proposed system. This is the outage probability versus SNR graph. This is the overall outage probability. And this is the fairness ratio versus number of femtocells. This is the fairness ratio versus number of femtocells values. This is the overall fairness ratio. This is the fairness ratio in bar representation. Here bit error rate graph between existing and proposed system by varying the SNR value. This is the bit error rate values displayed in table, the overall bit error rate values. And this is the energy efficiency graph by varying the number of femtocell between our existing and our proposed work. This is the energy efficiency graph values, and this is the overall energy efficiency. And this is the mean delay graph for our proposed and existing system by varying the number of users. Finally, we allocated the users to relevant resource blocks by performing optimization method. Thank you.